All right, let's take a look. So click and close. Let's have a little look here. What are we going to do? So what form is this in? What form do we say that's in? The stuff we talked about Friday. Which one? Not standard. Not vertex. We did go through this Friday, right?
Yes.
Yeah, it's the new one.
Quadratic.
Did we go? Did we go through an example of this?
Yeah, we
Friday?
did. We forgot.
The P and Q one? Okay, good. Okay, yeah, so but it's new stuff. There is an assignment up for this now. This is actually taken from the assignment. So these are the kinds of problems you're going to do. I think it's just 6 problems, of this type. This is our new form that we called factored form, right? Okay, so factored form because it's factored, isn't it? It's broken apart, it's factored. So factored form looks like a times, f of x equals a times the quantity x, remember? Minus P, good, times the quantity x minus Q, good. And we just said that A is A, right? We don't even really need A in this formula. It's always going to be the vertical dilation factor, right? But we don't even really need it in this case to come up with a sketch. Most importantly, what's P?
5.
Okay, but what do P and Q represent? P and Q,
The x, where it crosses the intercept.
good, where it crosses the y-axis, so they're x-intercepts,
X,
right?
You said x.
Are x-intercepts, right?
Oh, on the y.
So P and Q are x-intercepts, right? So it's where they cross, did I say it's where they cross the line y equals 0, right? Okay, so that's one thing. Now what are our values going to be for this one? We get P equals what for our function? Very good, -9, good. And Q is -5, okay? Good, so that's one thing, that helps us. If we, think about this, if we could ever get the vertex and 2 points, that's really all we need to sketch a parabola, isn't it? Right? We know the shape is going to be parabolic, but we need to know kind of is it stretched, is it compressed? How did we find the vertex for this? Do you remember? If P and Q, the x-intercepts are at -9 and -5, what was the x-coordinate of the vertex? H. How was H related to P and Q? Good, it's the average value. It's got to be halfway between, doesn't it? Because the parabola has that kind of symmetry, right? These are going to be mirror image points folded around the vertical line of symmetry, right? The vertical axis, which goes through the vertex, right? So H is just going to be the average of the 2 x-intercepts, right? So what's that give us here? H equals what's -9 and plus -5 divided by 2?
7. -7.
-7.
Oh, that's what I said on Friday, remember?
Yes.
I just didn't know why it was happening. I just knew it was
But
happening.
you saw it, that's what it was. How do we find the y value that goes with any x value for a function?
Put it back into the
Put it back into the function, right? If we want to find a y value, we plug in an x value to find the y value.
So
So K,
H would go where x are? Or?
it goes in where the x's are, exactly. Right, so K would just equal f of h, right? So for us, we'd be plugging in -7 for each of those x's, right? So K would equal f of -7, which is going to be 4 times, what's -7 plus 9?
-2.
2, good.
Times
What's -7 plus 5?
-2.
Now, as you do these, you're gonna notice that that pattern always shows up. When you evaluate these two factors, every time you're gonna get a number times its opposite. If you don't get that, you did something wrong. So stop it.
So if you get the first one, just put the other.
Right, you should just make sure that, I mean, do it though, to make sure you're on the right track. But you know that that's gonna be kind of a mental check. Am I doing this right, or did I mess up somewhere, right? So then what do we end up getting? 4 times 2 is 8, times -2 is -16, good. So we end up with our vertex then, has to be at the point -7, -16. So we'll just go find the right function then, right? With x-intercepts at -5, or at -9 and -5,
It's not those ones.
with a vertex at -7, -16. So tell me when.
Mr. Oya,
Yeah.
I'm
Mhm.
good. You lost.
Wait,
me at the
keep
K
going.
thing.
Okay, let's go back to the K thing. So we know that once we find H for any function, what are H and K represent? An ordered pair, right?
Yeah.
So it's an X and Y value that go together, right? For any function, whether it's a quadratic function or something else, when we talk about an ordered pair, we're talking about an input value and an output value, right? So if we want to find the output value Y, and we know the input value X, all we have to do is plug the input value into the function, and then the answer is the output, right? So does it make sense? Everybody give me a thumbs up, sideways, or down on how we got P and Q. Okay, good. So we can just match it up. We know that those are the numbers that are being subtracted from X. Good. Okay, thumbs up, thumbs down on how we got H. Okay, averaging the two values, no big deal. Good. Okay. So then the next one's no big deal either, because once we know the X value, H, if we want to find the Y value, K, all we have to do is evaluate F at H, right? So we're going to plug -7 into the function, which just means that this is going to be -7, and that's going to be -7, right? That's all we're doing. Say it again?
I can't see the.
Yeah, that's, so K, so let me rewrite that. It's just my crappy writing. So K is equal to F of -7, because that's H, okay? And so when I plug -7 in there, I'm gonna get a 2. When I plug -7 in there, I'm gonna get a -2, right? So I get 4 times times 2 times -2 is -16, okay? Okay, now, thumbs up, thumbs down on how we got K. Okay,
100%.
good. All right, so then all we have to do at this point is just go find that graph that has those 3 points, right? It has x-intercepts at -9 and -5, and a vertex at the point -7, -16. So, no, you tell me when you think you see it here. Ooh, that looks pretty good, doesn't it? Right there. X-intercepts at -9, -5, vertex at -7, -16. That's it, isn't it? Right. Okay, I'm gonna miss this one. Actually, see, can I do that? Yeah, I can. I'm gonna miss this one just so you guys can see what the feedback looks like. How about?
It's not gonna be that one.
Right, I'm missing it on purpose. I want to do the wrong one, just so you can see.
It's a lot.
So this is pretty useful. It's just going to go through that process. If this is the function, we're comparing it to the form right here, right? Comparing it to intercepts form, or factored form, we call it. And then we figure out what A and P and Q are. So it gives us the x-intercepts at -9, 0, -5, 0, right? We can average those to find H, which gave us -7, and then we just plug -7 into our function, and we get 4 times 2 times -2, right? So we create those 3 points and just make a smooth parabola. And for us, it means just finding that one that does that, right? Okay, good? All right. So that's not, it's a really quick assignment. There's not much to it at all. And this is, I mean, I don't think you'll have any trouble with this. I really don't. What I want to do today, and I would normally let you probably work on some stuff today, but I'm going to be gone. You guys get Wednesday through Friday. Are going to be nothing but work days, days where you can retake tests and work. So being as I'm only here 2 days this week, I'm gonna show you something a little different. Once again, though, it's not a big deal. This is a really, I think this is going to be a good. You'll like this. This is where you're reaping the benefits of all the work that you've already done. We're just adding some applications of in math that rely on being able to solve quadratic equations, right? So you're going to get some additional practice of solving quadratic equations while you do some cool new stuff. So for today, what I want to take a quick look at is solving a system, and we've solved systems before, right? We solved linear systems when we reviewed at the beginning of the year, right? We can solve linear systems by substitution or elimination method, right? So we're going to solve a system, but this time we're going to take this to a little higher level. We're going to solve a nonlinear system. So what's nonlinear mean? What's that mean?
It's not a line.
Not a line. Yeah. So in this case, one of the equations is not going to be a line, and the other one is going to be a line. But you'll be able to see here that you could generalize this, and I'm not going to go further than what we're doing. We're going to solve a linear quadratic system, and that's really all that Algebra 2 is expected to do. And so I'm not going to resist the temptation to go further than that. But you'll be able to see that we could very easily make this, for example, 2 quadratic equations, and it would work fine. Okay? It would work essentially the same way. So let's just take an example. Like what if, I'll pull one up, just one of the Moodle problems. And I don't even really have to probably say a lot about the theory behind this because you're just going to get it, I promise you. Let's look at, just something like, I'm going to pick a hard one. Yeah, let's pick one like this. Okay, how about something like that? Let me grab a picture of that. So let's think about this. We're going to dive into the algebra in a second, but what if we were to think about this in terms of graphs? What kind of equation is that?
Y equals mx plus b.
It could be written as y equals mx plus b, couldn't it? It's a line, right? So it's a linear equation, so if I graph it, it's going to look like a line. Sure. What about this one? It's kind of messed up. But I could, if I isolated the y, what would I get?
Mx plus b. You're going to have a squared in there.
Okay, I've got a squared in there, don't I? Right? If I were to isolate the y, and let's just do that.
Oh, you're going to get a parabola.
I'm going to get a parabola, because it's quadratic, aren't I? Right? It's not really written in a convenient way, but if I were to, let's just say we were to move the y over to that side, and move this stuff over to this side to make it look better, so the y is positive. I'd end up with a y on the left, and on the other side, well, what I get, if I subtract that whole thing, wouldn't I get minus the quantity x minus 1 squared? And then the minus 5 would just stay there. Everybody agree? Okay. What form is that in? That is a quadratic equation. That's vertex form, isn't it? Right? And so I would end up with a parabola and a line. And what do you think the solutions to this system would correspond to?
Where they intersect.
Where they intersect, yeah. Let's just do this in Desmos real quick, and let's just see that. And then we'll talk about a way we can find those solutions using algebra instead. All right, so where's my Desmos? I know I've got it on here. There it is. We're just using it in calculus today. Now, the nice thing about this is, look, we wrote that we solve for y, but in Desmos, what's kind of cool is I don't even have to write this. I don't have to isolate y, right? That's one of the real strengths of Desmos. Whoops. Is I could just do this. Let me get rid of all this stuff. I could just write it as is, right? I could write that as the quantity x minus 1 squared equals negative y minus 5. And I'm going to get, that's red, isn't it? So I'm getting the red parabola. And then if I graph the line 2x plus y equals 1, look what I get.
They don't connect.
Well, what do you know? They don't even connect. So what would I get if I tried to solve that one, do you suppose?
And then
Let's see. Let's see what we get. So here's an example. I mean, it's going to be something like that, right? There's going to be no, they don't cross. Okay. So let's just do this problem and see what we get. How could we go about doing the algebra? Because whether or not they cross, the algebra is going to be essentially the same. How do you think I could solve this system? Any suggestions?
I would start guessing.
Think about the ways that we solved linear systems, because those are just simpler versions of a system of equations.
What you do on one side, you gotta do the other.
That's true for any
Yeah,
equation.
Elimination or like the.
Elimination or
Substitution.
substitution. Technically, we could make either of those work, but usually when we're solving nonlinear systems, substitution is an easier thing to do.
Or you can make it equal to y and then fill it in there.
Exactly. Now let's look at this top equation up here. Which variable do you suppose we'd probably want to substitute for?
Y.
Why? Yeah, because look, it's linear. It's by itself and it's to the first power. Okay, let's put all phones and stuff away. I really want everybody's attention here because I feel like if I don't have you now, you're going to have a tough time recreating this later. Right, so y is a convenient thing to substitute for because it's not being squared, right? So I could make a substitution. I could say, okay, that's what I want to substitute in for. Let's use the second linear equation. If I just solve for y in the second equation, that tells me what I could substitute into the first equation,
You
Right.
subtract 2x, and then
right?
you get y.
Subtract 2x and get y by itself. Very good. Okay, so I'm going to go ahead and get rid of this stuff. We don't really need that. We don't need to put it into vertex form. So if I isolate y down here, I get y equals
Negative 2x.
1 minus 2x, or negative 2x plus 1, either way, doesn't matter. I'm going to put a box around that because it's my substitution equation. Right. Always put a box around the substitution equation. And then here's my y, right? So that's what I'm going to substitute into the top equation. Instead of a y, I'm going to substitute a 1 minus 2x, right? Now, think what the advantage of that is. Let's do this and tell me, in hindsight's always 20/20, tell me why I did this. So up here in this first equation, we'll call that equation 1. We've got x minus 1 squared equals negative y. But that's going to be negative this stuff right here then, isn't it?
Just gives
That's
us
my y.
the deals on those.
So where I used to have a y, I'm just going to put the quantity 1 minus 2x minus 5. Now what's so good about what I did?
Got rid of the y's.
I got rid of the y's, exactly. Now I've got an equation with only one kind of variable, right? If I have an equation with only x's in it, I can use algebra to solve for x, right? Okay, so let's just go through that process. Let's simplify things here. So what could I do?
You're gonna get -1 plus 2x minus 5.
Okay, so I could distribute the negative. On this side, I'm going to get -1 plus 2x minus 5, right? What about on this other side?
Then you're
Well, I'm going to have to square it out, aren't I?
Yeah.
Right, so I'm going to have to use my pattern, right? What's my pattern here? If I've got,
A squared
There you
plus
B
two
squared.
AB plus B squared.
okay, good, so I can use the pattern.
Well,
we can
minus
use-
two AB on this one.
Okay, we could use the minus one if we want to. Either one's going to work, but if we use like a minus b squared, that was a squared minus 2ab
Plus B squared.
plus b squared. So for us, instead of a and b, we had x and 1, right? So a squared would be an x squared minus 2 times x times 1 would be minus 2x. And then here I'm just going to get -1 squared is 1, right? Okay, so on this side we end up with x squared minus 2x plus 1. Good, so now we've simplified everything. We've expanded it out, we've distributed. Now what could we do? Because think what this is here. This looks a lot like stuff you've done, doesn't it?
Yeah.
Right? Combined like terms, sure. So over here, on the right side, -1 minus 5 is a minus 6. And then we'll just keep going. Which side do we want to collect everything on when we combine like terms?
Left.
Right side, because we want x squared to be positive, right? The coefficient of x squared. So we'll subtract 2x from both sides. We'll add 6 to both sides, right? And then we end up with, what, x squared minus 4x plus 7 equals 0. Quadratic equation in standard form. How do we solve those? We could complete the square, and this would be a convenient one to complete the square on, wouldn't it? Because we've got an even number for b, right? We'd try to, first of all, maybe see if we have magic numbers, but there aren't magic numbers that multiply to 7 and add to -4, right? So we'll go ahead and complete the square on this one. What's our other option? Quadratic formula, sure. Okay. So if we complete the square on this, let's see, we get x squared minus 4x equals -7. So I got to fill in some blanks. What's my perfect square on the left side going to be? Good. X minus 2 quantity squared. To get that, what did we have to add to both sides? +4, which means on the right side, our perfect square is going to be equal to the number -3. Well, we can already probably see what's going to happen. When I isolate x, what am I going to get? I'm going to get imaginary numbers, aren't I? Because think about the steps to get the x by itself. I'm going to square root and then add 2, right? So if I square root both sides, I get x minus 2 equals plus or minus, good, square root of 3 times I, right? Because I square rooted a negative. And then I'll add the 2. And so I get x equals 2 plus or minus the square root of 3i. Okay, so my solutions were imaginary, right? And if the zeros are imaginary, they don't turn out to be x-intercepts, right? Only real zeros correspond to x-intercepts, right? So what if we had done, we used completing the square, which is fine. If we had used, and I just want to draw all this stuff together for you a little bit, what if instead we'd used the quadratic formula? What part would we have probably used first? What is the quadratic formula again? If we have a quadratic equation in standard form, then x equals
-3b plus or minus square root b squared minus 4ac divided by
right? So we could have looked at the value of the discriminant, the sign of the discriminant. We can do this in our head. B squared minus 4AC. So B is, let's see, what do we end up with here? Here was our quadratic equation in standard form. So what's B?
Negative 4.
Good. A is?
1.
B is?
7.
So what's B squared minus 4AC? B squared is going to be
16.
16 minus 4 times 1 times 7 minus 4 times 7 is 28. 16 minus 28 is what sign?
Negative.
So we know because it's negative, we're getting no real solutions. And remember what that looked like in terms of a graph. No x-intercepts, right? So no place, when we look at this graph right here, this parabola never intersects 0, right? Which means that if we go back to our original problem, we got no real solutions, and so that would tell us that what we originally started with was a parabola and a line don't intersect, right? Okay. Let's pick one that works about. Okay. Well, I'm picking a hard one for you. Holy smokes. You guys are up to it, though. I know you are. Okay, so let's do this algebraically. What's going to be what variable do we want to substitute here? In the quadratic one, right? We want to substitute something into the quadratic one. Which one probably do we want to do?
Y.
Bottom one, solve for y. Good, right, because we have a y by itself. So in the bottom equation, let's come up with our substitution equation. It's easy to isolate y there. What do we get?
Y equals negative 2x.
Good. So there's our substitution equation, right? So now if we go to the top equation, we're going to get negative 2 times the quantity x minus 10 squared equals y, which is this stuff right there, right? Negative 2x plus 11. And I could put that in parentheses, but I don't really need them this time, do I? Plus 9. Okay, that's step 1. That's good. We eliminated the y's. We've only got one kind of variable, which is an x. Now what do we do? It looks like a mess.
You can do something else.
Okay, so we got to simplify this thing, don't we? Right? Let's start with the right side. On the right side, if I combine like terms, what do I get?
Negative 2x.
Aha. And on the left side, we get negative 2 times x minus 10 squared. So we can be smart about this. We could expand this whole thing out and distribute the negative 2, but do you see something we could do to both sides of this right now that might be useful? What can we do? Divide by negative 2. Why not? And that works because look at these coefficients. I wouldn't have done that if these weren't both even, but would you agree that 2 divides into both sides evenly? So much negative 2, right? You could divide by either 2 or negative 2. Negative 2 is better. So if I divide each side through by negative 2, on the right side, that's the same thing as dividing each term by negative 2, right? So the negative 2's cancel. What a great idea. That helped. Look what we end up getting. The negative 2's cancel there. And then over here, we're going to get, let's see, what are we going to get? 20 divided by negative 2 is we're just going to get a negative 10, aren't we? Right? So we end up with x minus 10 squared equals x minus 10. How about that? Did we have to do that? No, but it makes things a lot easier, doesn't it? Rather than having to multiply this out and then distribute, that made things a lot easier. That was a great idea. Okay, would have worked both ways. Now what?
The one thing.
Square
root.
Okay, we got to square this one out. What are we going to get? So that's a minus b squared gives us a squared minus 2ab. What's that going to be? What's 2 times x times 10? Good. Plus 10 squared. Okay, we'll collect like terms and see what we get. If I subtract x from both sides, I get x squared minus
21x
21x. Good, I'm going to subtract an x
plus 110.
from both. And then if I add 10, plus 110. Good, plus 110 equals 0. Can you think of numbers that multiply to
10 times 11.
110 and add to 21? Ah, very good. 10 and 11, right? So we could do this one by factoring. Makes things a little easier, doesn't it? Right? We can find magic numbers. We know that if magic numbers work, if they multiply to a positive and add to a negative, what's that tell us about the signs? If they multiply to both negative, good. And then the numbers are 10 and 11, right? Good. So if we find the solutions, then if we set those factors equal to 0, we get what? 10 and 11. Okay, let's look at the graph and just verify this. See that we did our stuff correctly. Okay, there we go. Okay, so we're graphing our original equation. Let me go up. Was negative, we're just going to edit this one, negative 2 times the quantity x minus 10 squared equals y plus 9. Okay, so somewhere on there's our graph, right? Okay, how about the line? The line should be 2x plus y equals 11. Okay, and if we look at this carefully, let's look at the intersections. What's the x value for that one? 10. What's the x value for that one?
11.
What do you know? It works. Okay, how about that?